radiation pattern charts are data you obtain from antenna vendors that are very precious for you to understand how the antenna radiates energy. The thing is that if you don't know how to read those, well, there is not much you do with those. Actually, there are two ways of obtaining radiation pattern charts, and they're all relative to the gain of the antenna. The gain of the antenna is something you have to understand clearly. Imagine a sphere, my isotropic antenna. It's going to radiate energy in all directions. It's going to be the same amount in all directions. The only thing that is going to vary is the distance, and as you go farther away, there will be less energy because it will be a larger sphere than if you're close to the antenna. That's the isotropic, but of course it doesn't exist. So when we use real access points with real antennas, and we try to give the measure of gain of that antenna, what we try to do is to try to compare how much more energy that access point antenna is giving compared to an isotropic antenna. So if you look at my sphere here, the gray area is the isotropic radiation, and the red area is what my antenna here is radiating. And of course, because it's a physical object, it radiates more in some areas and less in some others. And the thing to keep in mind is that we do not care about where it sends less than the isotropic. So the less area, the top, the bottom does not matter. What we try to measure is how much more it sends in the areas where it sends more than the isotropic, which is this small blue area here. So the antenna gain that you're measuring is in that area. You measure your antenna radiation pattern, you take the point or the direction where it radiates most, and you compare how much more that is than what an isotropic antenna would be radiating in a perfect sphere in that direction. That is the gain of an antenna. So you see, it's a passive gain, right? It's nothing that the antenna is adding. It's not sending more energy that it received. It just shapes the energy differently, and it shapes it by sending it more in one direction and less in some other. So some vendors can give you a radiation pattern with that kind of chart. That's actually what they measure in labs, right? So you have a 3D object that you can turn around, and that gives you all the spots where the energy radiates, and the color code gives you the idea of where that energy is. Typically not very easy to use and manipulate unless you have a 3D software yourself. Most of the time you want to have some representations that can be used in a way that is more handy for you, admin. So what they give you is typically a cut view of one view from the side and one view from the top. The view from the top could be from the bottom, right? It's just a vertical view. You're sitting on top of the antenna or below the antenna. It's called the horizontal plane, H-plane, because you see how it's being radiated on the flat space. The view from the side is called the E-plane or vertical plane because you're standing sideways and you see how the energy radiates vertically. So typically you get those two views, and you use these two views combined to try to understand how the antenna radiates in the other angles. So let's look at these radiation charts and try to see how they work. Actually, it's pretty simple once you understand the principle, but if you look at those numbers, you see on the circle there's -5, -10, there are angles. What does that mean? Well, the way it's done is that you take an access point and its antenna, and then you try to turn around the access point or the antenna. I'm going to say antenna because that's what we measure. And you try to find the spot where there is most energy. You just, measure that energy around and try to find a direction where that energy is highest. That is going to be your reference point for your chart. You could use any other point, by the way, but that's easy because that gives you a sort of a max value for your antenna. Okay, so you position yourself at that point. And then what you're going to do is that you're going to move around the access point and the antenna, and you're going to measure how much energy you have as you walk around the antenna. The trick is that you have to make sure that you stay at the same distance from the antenna. So that's the key thing. You do not get closer, you just stay on a circle around the antenna. And as you move, you measure how much more or how much less energy you have at any point from the energy you measured at that first red dot, which was your reference point. So you took the point of maximum energy so that you only have less as you turn around. But it could be any point, and you have some places where you have more and some places where you have less, but starting from the max is always easier. And you see that scale that is on the screen now. It measures basically those circles are values, dB values, where you have less energy there than you had at your reference point. So that means that I'm taking my first reference point, I know I measure energy, and how much energy I get there is not important. What is important is that it's a reference. Then I turn around, go a couple of steps, then measure that energy, and I see if it's the same or if it's less. If it's less, I'm going to measure how much less on that dB scale going down towards the access point, but it's just a representation. It's the scale that matters, minus 5 dB, minus 2 dB. And I keep on turning that way all around the access point. And at every single step, I'm going to measure how much energy I measured there compared to my reference point I am back to now. So I'll say here I had that max energy, here I had maybe 1 dB less, here I have 5 dB less, here I had the same, here I had 2 dB less, here I had 5 dB less, and I've got all these references all around my access point antenna. So you see, the amount of energy itself is not important, because if you crank up the volume on your access point, you put more energy, then you have more energy there. What is important is the ratio between the point of max energy and the other points as you turn around the antenna. And that's going to give you that reference pattern that you see like this, for example. So the green line tells you that, for example, at 330 degrees, I have about 3.5 compared to my max value. In this scale, I also represented the dB value itself to say I'm going all the way up to 4 dB, and here I have half a dB less. So you see, you could use any scale you want as you reference 0 as being your max, and then you go down minus 3, minus 5, minus 6, minus 10, or you measure how much you got that point, like I did here. I got 4 dB, and then I measure how much less I have as I turn around. But this maximum point doesn't matter in itself. It just matters as it helps you calibrate your reference points and then measure the others as you turn around. And this is how you get that kind of shape. This is what we call an omnidirectional antenna. You can get a very different shape like this one, for example, where there are some points as I turn around where I have a lot of energy, for example, at the bottom. There are some points on the side where I also have some energy, but some points where I have very low energy here, some drops here, and some points where I almost have nothing. So you see, it's a very particular shape, and it's very important because you're going to use that antenna in situations where you don't want to cover the sides, you want to cover one direction, and the back the other direction as well. And you know that this antenna is going to do the job because it has that radiation pattern. The antenna we had before with the circle would not work here because you would cover so much on the side, and you don't want that. Some other areas like a meeting room, for example, you want an antenna that covers smoothly, nicely in a circle, so you would not use that antenna. And it's only by having the radiation pattern chart from the vendor that you can see how that antenna is radiating and that you can decide what antenna is best for your job. Most of the time, there is not a guy with a phone turning around the access point antenna and taking measurements on the notebook. Most of the time it's automated systems like the one you see here, where the antenna is in an isolation chamber where no RF energy can get in, nothing, the ground value is 0. And then there is an automated system that measures in 3D in real time the radiation of the antenna, and that's automatically plotted into a computer that is going to reflect that 3D value that we saw at the beginning. So it's not actually measured by hand, it's automated. But the principle is the same, The tool basically does a 360-degree rotation around the antenna to measure all the possible angles, and that's how we get these radiation patterns.